Good afternoon, everyone. A very warm welcome to all our prospective students, parents, faculty members, and staff. On behalf of Dhirubhai Ambani University, I am delighted to welcome you to this open house session for our 5-year dual degree program in BSMS in Information Technology and BSMS in Data Science and Artificial Intelligence. Amit Mankodi, I'm a faculty here at DAU. I'll be moderating this session for today. So just to understand how this session will be designed, we will have a brief introduction of the Institute by our Dean Academic Programs, Professor Bhaskar Chaudhary. The next will be presentation on the BSMS program of in Information Technology that will be delivered by me. And then we will have the BSMS in Data Science and AI presentation by Professor Arpit Rana. And finally, we will open the session for question and answer. So without further ado, I request Professor Bhaskar Chaudhary, our Dean Academic Programs, to share a brief overview of the Institute, its vision, and academic philosophy. Professor Chaudhary.
Yes, thank you. I'm audible, right?
Yes.
Yes.
So, good afternoon, everyone, and I welcome all of you to this open house. I'm really glad to see so many participants and students, and it's very important that all of you are exploring such an important decision about your future. This decision is actually very critical because this decision is not about just choosing a university or just a degree. What you are deciding is, are you choosing a right environment? Are you choosing an environment which will help you to grow intellectually, which will help you to grow professionally, which will help you to grow personally over the next few years? And we believe that at Dhirubhai Ambani University, we provide that unique environment to our students. So as far as the academic philosophy at our institute is concerned, it's based on three simple but very powerful ideas. So first, we strongly emphasize on strong fundamentals. Second, we provide flexibility in terms of academics. And third, we provide you an opportunity to do a lot of meaningful hands-on learning and help you in problem-solving skills. And we strongly believe that the technologies are evolving very fast, as we have seen historically, and particularly with this rise of AI wave, we can see it's changing, every couple of months. So what is important in today's world is how can you develop skills, problem-solving skills? How can you build very strong foundation? How can you learn independently? How can you work in a team to solve complex interdisciplinary problems? And our programs are designed to reflect these ideas. So how we design most of our programs? First, students start with a core course, a set of core courses in first couple of years, which helps them in building a very strong foundation. And as they gradually move to higher semesters, they take electives, and that helps them in interdisciplinary learning, and gradually they get exposed to different kinds of projects, internships, industry internships, research internships. And this ensures that the learning is not just theoretical. There is a great deal of practical learning, and you get an opportunity to solve problems and real world challenges. I would like to highlight a couple of things about our newly launched BSMS programs. These have been designed with a lot of thought process, and they are really unique in nature. You will actually, if you do a survey, you will really find this kind of program, at least in the country currently. as we go forward, we'll explain the design philosophy and the program curriculum in details. To briefly summarize these two programs which we are launching from this year, that will help in very seamless integration of undergraduate and postgraduate students, and it will allow you to explore subjects and application areas in very greater depth. And this kind of application oriented and immersive learning can be really transformative. Another important strength of our institute is the faculty members. So we emphasize and we place a strong emphasis on bringing faculty members who have great experience in research, in industry, and they are very committed teachers also. So whatever they deliver in their lectures through classrooms, we see great deal of research coming there. And this ensures that students are not only learning from traditional textbooks, but they are also learning from people who are actually contributing to these fields. So the point which I try to emphasize is that you are taking a very important decision in your life. So you really need to understand how to take that decision, so that that decision turns out to be very informative decision. I mean, over the years, actually, if you look into our website also, you'll find a lot of data. We don't just prepare students for their first job. We prepare them for a lifetime of learning and growth. Many of our alumni have been at very respectable position, at very senior position, at technocrats, at CEO level. So they're actually building things, they're building systems, they're building companies, and we create that foundation through our programs. So if you are someone who is curious to learn and you want to put a lot of hard work, we're looking for an opportunity to explore, to question, to experiment, to discover your strengths, I think these programs can be life-changing, and you will find DOU overall to be a very good place for you. So to conclude, I will thank all of you, and I really look forward to a very interactive session. And I encourage all of you to ask a lot of questions, so that this will really help you in taking an informed decision. Thank you.
Thank you, Professor Chaudhary, for the insight about DAU and the programs. So the next, we will move to the first program presentation, which will be for BSMS in Information Technology. So I'll be sharing the slides and going through the presentation for this program. Are my slides visible?
Yes, sir.
Okay. All right. So let me begin with the introduction of the BSMS in Information Technology program. So this program is a 5-year integrated dual degree program, where the program allows a student to get the mastery in building scalable, secure, and intelligent systems. So the program will be for 5 years. Totally 200 credits will be completed, and the program offers multi-exit options supporting NEP 2020. So brief about DAU, which Professor Chaudhary has already mentioned. But basically, we are a premier institute, ICT focused. We have a research based ecosystem, and having a strong academic background. All our programs are also industry aligned, so students who go through our programs, get placement generally, at good places in good roles, and that you can observe through our placement statistics. So let us learn about information technology, and we want to understand why information technology is important for us, right? So as we know that the world is becoming digital more and more day by day. For example, a few years ago, we did not have UPI system. Now we have the UPI system through which you can transfer money to anyone just by using, a phone number or a name even, if you have the UPI ID for them. Secondly, for healthcare, as you may have seen, a lot of surgeries are now happening through robotics, right? For education, we do distance learning. For example, we can use virtual reality for educating students who are not actually on campus. We have built some systems for smart cities. For example, there are many cities where we measure the air quality index, right? And then we figure out that whether this air is breathable. If not, then what can be done about it, right? So similarly, what I mean to say is that there are all of these domains where information technology is needed. For example, in collaboration, today all of us are sitting in different cities, probably different regions of the country, but we are still able to communicate through this collaborative Zoom network, right? So all of these application requires information technology. So what are the key components of information technology? So I've listed out the major ones which is relevant to us. So cybersecurity is one. So where cybersecurity comes into the picture? So for any application, we need to store the data and transmit the data to multiple systems, right? So when we do that, we do need to protect our data, right? So during the transmission or during the storage, we need to protect our data, and nobody else should be able to get an access to our data. And that is where the cybersecurity comes into the picture. When we talk about IoT devices, for example, when you drive a car, when you go over certain speed limit, it tells you that you are going over, let's say, 80 kilometers per hour, or it measures the tire pressure and gives you the information that you need to feel the pressure, you need to have the air in the tire, right? So this is where the IoT comes into the picture. We all use web and internet day in, day out, right? Without Google search, it's very difficult to survive these days. We know that. AI analytics, again, AI is a buzzword which I'll talk more about in the next few slides. That where AI fits into this whole ecosystem of information technology. Everyone uses cloud, so when you use email, Drive, Google Drive, right, all of that data is stored on cloud in some sort of a database. And then finally, we have certain systems which we call telcos and BI. BI stands for business intelligence. So whatever data that we have, obviously we need to have the communication for the data to be transmitted to multiple systems. And in addition, why we need this transmission is because we want to make a strategic decision. What is a strategic decision? For example, when you look at the Amazon app or general Google search, what you will find that depending on the age group, you actually get the prompt, advertisement prompt of different products. For example, if the younger kids are looking at, site, they will be getting the advertisement of the product that generally the younger kids will use, right? If the parents are looking at the website, then they will be getting the information about such things. For example, your father may be getting the information about the investment products and things like that. So basically, these are all decisions made by the tools where the data is provided that this age group will generally look for this kind of product, right? And this all is part of information technology. Okay, so the next slide primarily talks about the misconception and reality. So what is a misconception? The misconception is that AI is everything. Everything can be done with AI. You don't need anything else. And that is a misconception. So what we are trying to say is that AI is not everything. AI is part of the ecosystem, right? AI is part of the ecosystem. AI also needs the data, right? Without data, AI cannot work because AI decision making is done based on the data collection, right? AI software will require some coding to be done, right? So systems has to be built in some software for AI. So for example, when you use ChatGPT, Gemini, somebody has to actually do the coding for this system. Somebody has to actually tell the model that, where the data is, how to learn from this data, right? So that information is still needed. The information about, the data and the software is stored on the cloud platform, right? And we need security frameworks because different systems will communicate through the software and through the data. So again, as I mentioned earlier, cybersecurity is important here. So you need the security framework to ensure that your data is properly encrypted when you transmit the data, right? So AI depends on these technologies, right? So without these technologies, AI cannot work. So that is why the slogan says that without IT, AI cannot scale or survive. So what is an information technology? So information technology is basically building, managing, and securing your digital systems. And as I mentioned earlier, we require different components. We require networks to connect multiple systems. We require databases to store our data securely. We require cloud infrastructure to have our softwares running there, and we obviously need tools for developing that software, right? So these are primarily the core areas which will be needed, and the one that you see on the right hand side, these are the areas that is covered as part of the BSMS IT curriculum. So we are not just imparting the knowledge about coding. So that is again sometimes a misconception about IT area, that IT is nothing but a coding, but it's not only coding. It is basically you are learning how the system works end to end, and you are also basically making sure that there are no issues when the system is running, right? So you have to not only create the system, but you have to maintain the system so that there are no issues in the production environment. Okay, so BSMS IT has 3 exit points within the 5-year span. So the 3rd year exit will be called Bachelor of Science. The 4th year exit will be Bachelor of Science Honors, which we call BS. And the 5th year is the Master of Science, MS, right? So the student, depending on their capability, capacity, and where they want to reach, right, they can choose to exit from the program. So it gives you basically flexibility, depth, and also specialization. I'll talk about specialization when we talk about the program curriculum. So these are the 5-year curriculum in a nutshell, in a very brief, actually I've given, right? So year 1 is going to be your foundation year. So year 1 is going to be same for all students, where we study the basic fundamentals such as computational thinking, problem solving, basic programming, right, mathematics, and things like that. So this is a very foundation year where all students go through the same curriculum. Now when we come to the 2nd year, in SEM 4, we actually start with the specialization. So in essence, what we are doing is we are actually starting the specialization quite early. The reason is because so that the student will get an opportunity to actually go much deeper into this specialization rather than exploring towards the end of the towards the end of the program. It is better that student starts exploring the the specialization in the beginning, right? So in SEM 4 you will start with the specialization, and SEM 2 will also year 2, which is SEM 3 and 4, will cover the core of IT, right? So the courses of the core IT will be also covered there, right? So in year 2 you will just have a single elective for a particular specialization, and specialization we have already mentioned, there are 4 specializations currently, right? Depending on the number of students enrolled in this specialization, we will offer one or more, all 4 as well, right? So we have the 4 specialization which are called administration and operation, right, where students learn how to manage the production environment. When the applications are deployed and when it's running in production, how do you manage that, right? The second specialization is on the security side, cyber security. Third specialization is the software engineering and development side. And fourth specialization is data analysis and artificial intelligence. So there are 4 specializations in this particular program. Third year, we go deeper into the specialization. So there will be less number of core courses, more number of elective courses or specialized courses. Year 5 will be focused more on the enterprise application. So what happens is that in year 3 you will study more deeper into the specialization, and you would have finished almost generally majority of the core courses. So now you have a very good idea about what IT is and what the specialization is all about. So what you would do is in year 5 you will actually apply your learning into the enterprise level application building, right? So in year 4 we have a lot of project component where you will be learning the domain knowledge as well. So we request student to actually learn projects through some domain. So for example, you can build a project on finance industry, you can build a project in the environment area, you can build a project in healthcare area and things like that. And then year 5 will be the final year where you decide where you want to go. So you want to go in the research track, then in year 4 and 5 you can do thesis. If you want to go in the industry, then you will do the internship. So semester 10 is going to be a complete internship where you go into the company and you study, you basically solve the problem in the company as well, right? There is one more internship which is after 3rd year, which we call summer internship. So after the 3rd year, the summer of that, there will be an internship, and then there will be a second internship which will be in semester 10. So this is basically the 5-year learning journey for you. So how are the tracks evolved or specialization evolved? So these 4 specializations are, as I mentioned, starts at semester 4, where you will be first exposed to the foundation of that particular elective. Semester 5 and 6, we will have the application of the specialization. So there will be some courses that will tell you how to use this specialization more in the applied manner, in the sense how do you build something through this electives, right? In the 7th and 8th semester, we will be talking more on the industry tools, and then semester 9 and 10, as I mentioned, it will be more on the expert level. You will work on the projects, you will work on your internships and things like that, right? So this is how we are planning to do. We also have planned that some of these topics, because they are industry oriented, we are also going to be having some industry expert actually deliver some lectures for these specialization electives. Okay. So in IT, we do have AI component. It is not completely neglected, right? But the AI component which we have is learned through some specialization. So we have machine learning component which is general to everyone. So all the students will be learning fundamental of machine learning. The deep learning and AI systems will be specific for a specialization where students would have chosen data analysis and AI track, right, or AI specialization. ML Ops is the topic that is covered in the data analysis and AI specialization, as well as in the administration and operations specialization, right? So again, AI part is definitely covered, but they'll be covered as needed for the specific specialization. Okay. So we built in the industry exposure by incorporating a lot of projects. So the first 2 years, it will be more of theory, labs, fundamental, things like that. Starting from year 3 onwards, you will see a lot more hands-on exposure, right? So we will have a lot of hands-on exposure where people will be working on the applied project. As I mentioned, after the semester 6, you will have the summer internship where you will get a chance to go into the industry and then work on the projects in the industry. In semester 7, 8, and 9, we have domain-specific projects. So as I mentioned, you can pick a particular domain and you can actually work on this specific project through semester 7, 8, and 9, right? And then semester 10 is a full semester internship. Now, if as I mentioned earlier, there are option of doing the internship if you would like to go in the industry for the job, or if you would like to work on your research problem, then again you can do that in your last year or so. So what are the career options we have? I've basically given career options for different specialization here, or tracks that we call. So cloud and operations, if you do administration and operation, you can be, you can have a potential role as a cloud engineer, DevOps engineer, ML ops, AI ops, and things like that. If you are in the security track or specialization, then you would get job like cybersecurity analyst, software engineering, you can be a developer, architect, project manager, and so on. Data analysis, AI, you can be a data engineer, AI engineer, and so on. So what is uniqueness about this program? So uniqueness about this program is, we start the specialization quite early so that you can get more exposure to the specialization. You learn not only software development, but also how to build systems through cloud infrastructure, right? As I mentioned, AI is exposed, integrated, depending on the need of a particular specialization. We have multiple career trajectories, in the sense we have multiple exit points, multiple pathways, and it offers you a blend of research and industry exposure. So again, a common thought that usually we have is AI is a future, which is true, but then AI needs a strong IT systems to work, right? So student will go through the foundation, the core systems, specialization, advanced technology, internship, capstone project, and the final internship. So thank you for listening, and this is basically about the BSMS in Information Technology program. So related to this program, if you have any questions, I think we will take it at the end once we finish both the presentations. I'll stop sharing now. Okay. So now I will request Professor Arpit Rana to present the BSMS in Data Science and AI program.
Thanks, Professor Amit. So, am I audible?
Yes, sir, you are audible.
And my slides are visible?
Not yet. Yes.
Now it's visible. There is one pop-up window.
Okay.
Close it, sir.
Okay. So, hello everyone. Welcome to BSMS in Data Science and Artificial Intelligence at Dhirubhai Ambani University. Uh, First of all, the declaration that whatever the images that I am going to use in this presentation, they are mostly AI generated, but I am going to use it only for illustrative purposes, so there are no copyrights. And now we are going to talk about this uh, BSMS in Data Science and Artificial Intelligence. The overall slogan that we have given to it is like we want to empower the next generation of AI architects. That is the overall motive for this program. Um, as Professor Bhaskar, the Dean Academics, he has already mentioned about the USPs of this institute. Still, I'm going to highlight three main points about it, which is top class, world class faculties here. They are PhDs qualified, PhD qualified faculties from IITs and top global universities worldwide. And along with them, there will be some of the courses that experienced industry experts will teach you in this particular program. There are flexibilities in terms of exit because this program is very well aligned with NEP 2020 guidelines. So as Professor Amit Mankodi has already talked about, that there will be three different exits. After 3 years, it is BSc. After 4 years, this is BS. And after 5 years, you will get both the degrees, BS and MS, both. Fine, because this is a dual degree program. Then the third one, which is one of the most important point about this program, is that it follows the global standards. Whatever the curriculum that we have designed, this is benchmarked against top global universities worldwide, and this is quite aligned with top international guidelines. So benchmarked against top universities means there are certain benchmarking criterias on the basis of which curriculums are rated. So the rating of this program is more than 9.4 out of 10 as per those standards. So the primary question that comes to you guys and to us being an institute or an organization is that what kind of education does the future of AI really need, as this field is quite early, quite evolving, like as every quarter you will see lots of updates in it. So what kind of education, for example, if whatever you are going to study, what if it will become obsolete by the time you finish your degree? So that is the biggest challenge in this particular field. So that is why this is the crux question, that what kind of education does the future of AI really need? So the artificial intelligence and data science, because that is everywhere, is specifically touching almost all different sectors, right from healthcare, finance, education, climate action, businesses, manufacturing, agriculture, etc., and so on. But the success in these fields require more than learning specific tools. It is not about learning AI tools, but it is beyond that. What is that? So it requires people, an evolving field requires people who can understand these systems, these AI tools, AI systems deeply. So first of all, deep understanding is needed. Second, they should also be able to design or build systems responsibly. What do we mean by building systems responsibly? I'll tell you in the next couple of slides. And then the third point, that these professionals who are basically going through this field or they want to build their career in this field, they should be able to adapt to the change because the field is evolving in its nature. So this is the right educational model that we have employed in this particular program, keeping into account these three main pillars of this program: understand deeply, build responsibly, and adapt to change. So these are three important facets or properties or characteristics that a professional should have if he want to build his career in this field. Another point, as I can see, lots of questions are also being asked in this particular open house, that what is the difference between science and engineering? They are talking about difference between BTech and BS and all that. So overall, I am saying that in general, what is the difference between these two? So first of all, if we just say that as per the definition, science basically asks for why something is happening. Whenever we talk about any machine in this particular context, we are talking about a particular AI system. So why this works, what is the reason behind it, and what are the principles through which it is being driven, right? If you are talking about a mobile phone and a smartphone specifically, so what exactly are the principles which are working behind it, right? So whenever you want to understand the reasons behind things that you are using or AI systems that you are going to use, so those reasons and the corresponding principles through which it is driven, all of that understanding comes from science. Fine. Whereas engineering, here we try to build solutions for the problems that we are facing. So how can we use it in the real world? If you're going to design certain systems, so how you are going to use it in the real world to solve certain problems? How you can actually make it more reliable, more usable for the users, more scalable means to a wider range of, so that it can serve to the wider range of audience. So engineering basically gives impact, whereas science gives understanding. Clear? Now, so in other terms, in more simpler terms, you can say that science will give you the answers of whys, whereas engineering will give you the answers of usability or applied knowledge. Fine. Now, the thing is that data science and artificial intelligence is a field which needs both. You need theory that will help you understand the intelligence behind that AI system that you will be developing. At the same time, engineering, without engineering, you won't be able to build those systems. Right? So theory will give you the understanding, and then engineering will help you will make you capable to build those systems. Clear? So without theory, students become merely the tool users. They will only be able to use those tools. Fine. AI systems as tools. They will only be able to use those tools, but they will not be able to build them or make corrections in those systems. Whereas without engineering, all of your understanding, if you only rely on science, then all of your understanding will be on paper. You won't have the applied knowledge, how you are going to deploy it, how you are going to create systems out of it. Fine. So that is why data science and AI, which is a specific field, and this needs both. And that is why we say that the future belongs to those who master both the science and the engineering, specifically in the field of data science and artificial intelligence. Now the question is that more or less science and engineering and the blending of these two, reasoning as well as applied knowledge, both of these two are required in almost all the engineering field. What is special in data science and AI? Why we are saying that there is a need of, explicitly saying that there is a need of blending these two streams. So what is specific in data science and AI, which is not available in any other engineering streams? So that is the difference, the new AI engineering reality. So that reality is here, guys. Listen carefully. The classical engineering, whenever you are going to build any system, I'm saying not AI and data science, not AI system, but any other system that you are going to build, for that inputs, whatever you are going to feed as an input to those systems, they are basically structured. Structured means they are somehow easy to handle. Fine. And whatever your system is going to do on top of those systems means how your system is going to behave using that particular input is almost deterministic. We already know what will be the outcome. For example, if you are going to feed 2, numeral 2 into a function which is a square function, you know that the outcome will be 4. Fine. Because this is a deterministic function. Fine. Whereas in AI and data science, the field is probabilistic. Most of these systems are, we would say, based on approximate solutions. They are not going to guarantee you for that particular solution. They are basically probabilistic. So uncertainty is intrinsic in this particular field. This field, as Professor Amit Mankodi has already highlighted, that this particular field is dependent on the data. If data quality is good enough, you will get good enough outcomes. And the third one is that it needs to be adaptive. Fine. So as context changes far faster than specification, for example, nowadays, whatever you are going to study in very first year, probably by a second year, you will have another advancement on top of it. Clear? So this is a field which requires adaptivity. Right? So that is why that's the difference between classical engineering and if you are going to do something, you are going to do a degree program in data science and artificial intelligence. So that's the nature of it. And to cater this nature, that is why industry have different types of needs. They want professionals who can solve new problems, not existing problems. You are not going to build a solution. You are not going to build systems that are already there. You have to adapt your system to a new environment, to a different context. Fine. So solve new problems, improve existing systems, and most importantly, handle uncertainty, which is intrinsic to this field. You need to design trustworthy solutions so that people would be able to trust you. Fine. Trust you means your systems, the AI system that you have deployed. So ultimately, industry really wants architects of intelligent systems. Architect means they should be able to understand the concepts as well as able to apply those concepts to real world, to build real world solutions. And that is what is missing. So this evolution, because of this field, this is relatively a new field, data science and artificial intelligence. So the evolution from tool-based degree programs or tool-based thinking to system level thinking is not fully addressed in conventional curriculum available in Indian context. And that is why there is a need for such a program that blends both the things. System level thinking, I mean to say that science and engineering both, which will give you thorough understanding of the systems, but at the same time, you would be able to build systems end to end. So for parents and students, whatever I have just talked about, why does it matter? Why you should listen to all of this? What is the difference between science and engineering? Why AI and data science is new and what are exactly is the demand? Because the main challenge of this field is that technology in this field changes rapidly. Because technology changes rapidly, careers also evolve constantly. And that is why the safest investment is an education that builds adaptability, problem solving, and innovation, the three key points. If you are only familiar with the AI systems or the tools that you are going to use, it's not enough for this field. You have to be adaptive. You have to keep innovating new solutions to the problems that are there. Fine. So that is why industry and the societal needs are that we need thinkers who would be able to understand AI deeply. They are not only coders. They don't not only code, but also would be able to understand AI technology deeply. We need builders who can construct reliable solutions and systems for the future. And we need leaders who can guide these AI tools or AI innovation responsibly for the society. So taking all of that into consideration, BSMS program in data science and artificial intelligence is aimed at preparing graduates with lifelong relevance, which has been the key of this premier institution, that we want our students that they will be able to relevant in the industry lifelong. It's not like after few years of their engagement with industry or in academia or whatever field they choose, they will become irrelevant. But we want them to inculcate the knowledge so that they will become relevant all the time. And that is why they will not simply use AI. These students, specifically in BSMS and Data Science and Artificial Intelligence program, they will not simply use AI. They will understand it, they will shape it, and at the same time, will apply the knowledge that they are going to get from this program responsibly so that it is socially aligned. So that is the overall objective of BSMS in data science and artificial intelligence. Now I am going to tell you that how we are operationalizing it, how we are implementing it through our curriculum. So our educational philosophy is that we want to inculcate the deep understanding of this field in the initial years, and then they will be able to move to the advanced application. Fine. So as you can see in the trajectory of these 5 years of BSMS in data science and artificial intelligence program, that in year 1, students will be able to work on, or they would be learning foundations of this program: mathematics, statistics, and computing. Most part of computing will be covered in year 2, where you can see modeling and systems. Computing means courses related to computer science, which is the foundation of this program. Then year 3 onwards, you will be working on machine learning and deployment. Frontier in year 4, frontier and applied AI courses will be related to that. And ultimately in year 5, whatever you have learned in first 4 years, you would be able to implement all of them with either you will go for research track if you want to go for research, or if you would like to go for industry, you can actually move in that direction and you will go for industry internship in the last semester. As it is available in MSc Data Science, MSc BSMS in Information Technology, that after 3 years, you will have a summer internship. Similarly, in this program also, you will have to go through that summer internship after year 3. So here what I'm trying to say is that in the first 2 years, you are going to build your foundations in mathematics, statistics, and computing. Fine. And then in the next 3 years, you will be exploring your interest through different types of electives, technical, domain, open electives based on your interest. You see, electives means, for example, there are different modalities. Modalities means you can build your system which works on text. For example, conversational agents nowadays, you might be working on Grok, you might be using ChatGPT, etc. So all of those are specifically almost they use text. Fine. So either you want to work on text, or you want to work on images, or you want to work on time series. Time series means if you want to predict weather for tomorrow, if you want to predict that there will be some catastrophe in the northeastern region of India in next 3 months, all of these type of things, or if you want to work on speech signals. So these 4 different modalities we are going to cover, but based on your interest. So you would be able to choose these modalities. That okay, I want to do a course on natural language processing, or computer vision, or digital image processing, or speech communication, or time series. So it will be available at your disposal. Fine. So you are going to do it. You are going to use these, explore your interests from year 3 to year 5 through different types of electives. There will be domain electives also that I'll talk to you later. So overall, in this particular trajectory, as I'm reiterating the objective of this program, that we are preparing graduates who can think, build, deploy, and responsibly apply advanced AI across different domains. Domains means different sectors, different fields, healthcare, manufacturing, agriculture, etc. Now, specifically in this program, students are given more flexibility in terms of elective baskets. So all the elective courses are specifically splitted or clustered into 4 different groups. Fine. So you would be able to select courses. Different clusters will be activated in different semesters, and based on that, you would be able to pick courses from that particular basket. Here, specifically, I want to talk about domain and analytics, where you will be working on, at least you are required to work on 2 different domains. Domain means you will have to develop applications to solve certain problems of what two of the domains. Domain means either finance or healthcare or manufacturing or cybersecurity or agriculture or business automation, etc. Right? So you will select domains and then you will develop project in those particular domains. Career pathways. So in terms of career, because this program blend is basically a blending of computational rigor and societal orientation, because that we are going to provide through different types of electives, open electives, I mean to say. So that enables the students to pursue impactful roles across research, industry, entrepreneurship, and governance. So there is a myth that BSMS programs are aligned more towards research. That is just one type of outcome. You can go for industry and corporate jobs. For example, you can look for data-driven roles for example, data scientist, machine learning engineer, AI engineer, quantitative analyst, data engineer, and more. You can go for research and higher studies. You can go for pursuing a PhD from premier research institutions in India and abroad. You can actually come up with something that you can build a solution, a scalable solution that is basically you are turning it into a business solution. Means you can start your own startup, or you can work for in the area of AI for social good, where you can come up with the policies, or you can become a policy analyst, you can become a consultant or technology policy advisor. So there are different avenues of jobs and roles available, and a student who is going through this trajectory, all of these avenues will be open to him. So if you want to prepare the future of data science and artificial intelligence, you should choose an education that is deeper than tools. It should go beyond tool level understanding. It should go broader than the theory. It should not only talk about theoretical understanding, but also the applied knowledge. It should not confine itself to tools, but it should give you the knowledge, what is happening underneath it. Fine. So that is why I choose a program that develops both intellect as well as impact. And that is the purpose of BSMS in data science and artificial intelligence.